All right, folks, I'm back. This is chapter 2-1. This is recording number 2. Okay, where we left off, I was fumbling around here with this table here, and what I was trying to explain to you is that we have class limits and we have class boundaries, and it's very confusing about which one is which. I think it's pretty much explained here when he talks about this first paragraph here, talking about what the class limits are, and then he talks about the class boundaries. I think the basic idea is this, that if you have class limits, you go from 58 to 64. The class limits are in the same units. They're same decimal place value as the data. The class boundaries, the intent of the class boundaries is to prevent gaps. So 58 to 64, and then we go from 65 to 71. Well, what if it was a 64.5? What if it was a 64.3? What if it was 64.7? The idea is that these boundaries prevent there from being gaps. So that's what he's talking about right here when he talks about the class limits should have the same decimal place value as the data, but the class boundaries have one additional place value and they end in a 5. And like I've said before, you take the lower limit, you take away a little bit, take away, in this case, 0.5, and then on the upper limit, you add a little bit, in this case, 0.5, okay? I hope that helped. So he kind of explains all this here. I hope it's straightforward. The key to this is to read this, try to get the best understanding as you can, but then what you do is you go to the example. If you go to the example makes everything very clear. And what you might have to do is bounce back and forth between the example and the explanation. So let's take a look at the example here. We got this record high temperature. Well, first thing I observed is we got all this data here, and it's in integer format. It's what the author was calling decimal place value is ones, right? It's 112, 110. So we don't have tenths, we don't have hundredths, we have ones. Okay, so it's 112, it's 100, and so forth. So this is a record high temperature. All right, so to find the classes, what's the highest value and the lowest value? The highest value, if you look at all this, is 134. The lowest value is 100. Therefore, the range is 34. So it's 100, or excuse me, 134 take away 100. So you select the number of classes. Usually you want, 5, 6, 7, somewhere around in there. So when you do that, you do the division and you come up with the class width of 4.9. Well, that's an awkward one, right? You don't want exactly 4.9. So we're going to round it up to the nearest whole number. So we'll round it up to 5. Okay, so we round it up. Okay, so and then you select a starting point for the lowest class limit. Okay, it can be the lowest data value or any convenient number that's lowest than the lowest data value, the smallest data value. So what he chose was 100. That was the lowest. That was the lowest value, right? He just told you right up here that the lowest value was 100. So do you see what I'm getting at here? Is you just walk your way through this, pencil and paper in hand, write things out, and it's not as bizarre and confusing as you think it is. I can't do it for you. You've got to do it yourself. You've got to walk yourself through this with a pen and a paper in hand and write this stuff out. The class boundaries is just like we said before. It's a little bit less and a little bit more. If the class limit is 105 to 109, the class boundaries is going to be a little bit less. It's going to be 104.5 and a little bit more, 109.5. You do your tally, boom, you come up with your frequency. So here's the frequency distribution. And the only value to this is that now you can look at this and you have a little better idea of the data. You have some idea of what to do with it. Now, I don't know exactly what you would do with this. It depends on your situation. Like maybe you're trying to decide, you're a city manager and you're trying to decide how, when do you want to open up the cooling centers, and if you get a heat advisory. Well, how often do we get these heat advisories? What are the ranges of temperatures? It could be any number of things, okay? But the point of the story is this is just a metaphor, and it gives you an idea of how to do this, okay? All right. So now a cumulative. I hope you've heard the word cumulative before. When you when you have cumulative, you are accumulating. You are it's a number of data values less than or equal to a specific value. So it's it's going to be a little bit different. It's not going to be, you know, we're not talking about how many are between 115 and 119. We're not talking about that. We're talking about how many are less than 115. Here, we're not talking about how much is between how many are between 125 and 129. We're talking about how many are less than 125. So that's what he's talking about here. Okay, so I'll let you walk your way through that. It's very straightforward. Just crank it out, pencil and paper in hand, and you'll see exactly how to do this. Okay. Okay, so this here was what he was referring to as a grouped frequency distribution, and and we use a grouped frequency distribution because there's quite a bit of a range, right? It goes from 100 to 134. If we were to just go down here and say, well, how many are at 100, how many at 101, how many 102, it would be unworkable, right? We'd have 35 uh, rows here. That's not very practical. So that's why we use the grouped frequency distribution. We put them in groups. However, there's another situation where we do not need to have the grouped frequency distribution, and that's right here, when the range of the data values is relatively small. And that's just in the eyes of the beholder. You have to decide for yourself if it's appropriate or not. But when the range of the data values is relatively small, a frequency distribution can be constructed using single data values for each class. So instead of having a class that goes from 100 to 105 or whatever, we just have individual rows. So this is called an ungrouped. It's ungrouped because we're not putting it into groups. So here we have a number of hours the college kids are sleeping every night. Okay, so how many classes are there? Well, the range is pretty small. The biggest number is 10. The smallest number is 5. So there's only 5 categories. We don't need to put them in groups. Okay, so there, we can have a single data value, and here it is. 5, 6, 7, 8, 9, 10. There's only 5 rows that we need to be concerned about, so there's no reason to put them into groups. So again, let's take 6. How many kids slept for 6 hours? 1, 2, 3, 4, 5, 6, 7. 7 kids slept for the 6 hours. The class boundaries, same as before. It's integer values here. It's 6 or 7 is integer values. So to use the author's terminology, the decimal place value is 1. Okay, so we add and subtract half of 1. We add and subtract 0.5. So it's a little bit less than 5. That's 4.5. A little bit more than 5. 5.5. Same here with 7. 7, we go a little bit less. We go down to 6.5, and we go a little bit more, 7.5. That way there's no gaps. See, because otherwise, if a kid reported, well, I slept for 7.2 hours, where would you put them? Would you put them in 7? Or would you put them in 8? Well, you put them in 7 because that's my class boundary. My class boundary goes all the way up to 7.5. If a kid says, I sleep for 7.5 hours, the rule is you go to the next higher one. So you go to this one. That way there's no misunderstandings about how the data is classified, or which category it goes into, or which class it goes into, I should say. All right, so I'm going to let you finish this because this is boring as dirt, okay? The rest of the class will not be this boring, trust me. Okay. All right, so these are the different reasons we do this. We do it because we want to organize it, because otherwise, what's the point? What's the point of having this data if we can't organize it? What's the point if we can't show it to somebody and do something with it? Explain why do we need a new fire station? Explain why do we need whatever it happens to be. Okay, so look through these exercises. You don't have to do them, but they're very helpful to kind of give you good examples. Okay, let me see if I can find a good example for you. All right, here we go. Coffee flavor. We did a survey and they decided, what's your favorite coffee? Well, if you're the guy that is in charge of buying coffee beans for Starbucks, you'd want to know this information because you want to buy the appropriate amounts of each type. Okay, you don't want to buy too much of one and not enough of the other, right? I mean, it's just common sense. All right, so that's something that might be of interest to you. It may not be interested to you, but it's of interest to somebody. Okay, all right. So these are all examples that we can all understand. You will find your own examples as you go through your own studies that are of more interest to you, and hopefully a little more interesting to you. I got a couple more minutes left on this video, so here's an example of something I find interesting. This is average wind speeds. So they talk about average wind speeds, they gather the data, you create your thing, right? Instead of wind speeds, let's take this as being high tides. Let's talk about what is the or a surge, a wind surge or a hurricane surge. If you were looking at averages of hurricane surges, how high does the water go? If you were foolish enough to build your seawalls based on the average, you would have a horrible situation come up eventually because on average it might only be a certain level, but it can be more than average. And this has happened in the past where city engineers make a mistake and they don't understand the difference between averages, and they don't understand probability, and they don't understand how data is organized. And so they say, well, the average height of the water, the average water level is some number, we're going to build to that, and it can be a real tragedy. So this is kind of an example, sort of what I'm talking about. A little more interesting than coffee beans, perhaps. Okay, so that's it for 7-1. Okay, sorry, I misspoke. That's it for chapter 2-1. Chapter 2-1 is this frequency distributions and graphs. So now we're going to go and talk about, okay, I'm close. All right, so that's it for 2-1.